Hello students, welcome to the engineering chemistry lab. Today we are going to discuss about or do the experiment about the size dependent color variation of copper oxide nanoparticles by spectrometry. Before that, I want to acknowledge, thank Dr. Chandan Maiti for making this experiment practical, and then Mr. Shivaraj for his assistance. Okay, so before going to the real experiments, let's talk about the synthetic and then characterization part of the nanoparticles. And then nanoparticles are very small particles which are of 10 to the power of -9 meters, okay, which we cannot see by our naked eye. Okay, so in broad way, these nanoparticles can be synthesized in two broad ways, that is top-down method and then bottom-up method. The top-down method involves breaking down the bulk material into smaller particles, breaking into smaller and smaller till the point it reaches the nanoparticles, or else the bottom-up process where the atoms either which is in the solution can be reduced, made into atoms, and then they combine together, cluster, and then you end up with the nanoparticles. Okay, and then to get more information about this, it can be either synthesized by physical method or the chemical method. Under the physical method, we can do ball milling process, means crushing the bulk materials to nanoparticles, or you can do gas condensation or chemical vapor condensation or laser ablation to get the nanoparticles. Coming to the chemical method, wet chemical synthesis, that is sol gel method, or precipitation method, that is by reduction process, we can arrive or achieve these nanoparticles. Okay, in our experiment, we are going to adopt this precipitation technique. Okay, so more interesting about the nanoparticles are, okay, so once the bulk material which goes to the nano regime, they started showing very interesting properties, interesting electronic properties, optical, mechanical, and then magnetic properties. And then these nanoparticles not only restricted to the metals or metal oxide, it can be silica, it can be polymers, it can be carbon-based materials. Okay, coming back to our experiment, okay, which is about carbon oxide nanoparticles. So how these carbon oxide nanoparticles are prepared. Okay, the main source for this main source for this copper is the copper sulfate. Okay, or combination of copper sulfate, sodium carbonate, and then citrate, sodium citrate. Okay, so it forms a copper solution. Okay, and then what happens is, like, when you combine all these chemicals, okay, so you have to take the Benedict solution. Again, I will repeat it. Benedict solution is the copper sulfate, sodium carbonate plus citrate solution. To that we can add glucose, okay, which is having the aldehyde group in it. Okay, in presence of sodium hydroxide, we need to add a sodium hydroxide. We'll go back to the tabular column. I can show you that this is the Benedict solution and this is the reducing agent, and then we may add the sodium hydroxide, which will increase the rate of the reaction. Okay, and then you can see that in the first process, which is an oxidation reaction, gives away the 2 electron, and then in the second step, okay, you can see that the copper citrate solution, which is in 2+ oxidation state, takes up the 2 electron in presence of base, and then it forms the copper oxide. You can see that the copper has been reduced to oxidation state, reduced from copper 2 to copper 1. Okay, and then this is the overall reaction. Okay, so let's go to the experiment. Okay, the first experiment, first part of the experiment is we are going to measure the optical properties of the copper oxide. And then interesting thing about the nanoparticles are, okay, whenever we change the size of the nanoparticles, they will exhibit different colors. That is because of the surface plasmon resonance. Okay, say for example, if smaller the size, it will show a different color, larger the size or bigger the size, it will show a different color. That's because of the amount of electron cloud that may be present on the surface of the nanoparticles, which respond to the incident of the light. Okay, so let's go to the experiment. Okay, so what we have to have is, like, we need to have a Benedict solution, okay, so which is a bluish color, and then a glucose solution, and then a sodium hydroxide solution of various concentration. Okay, let's do the experiment. Okay, students, let's start the first part of the copper oxide nanoparticle synthesis, which involves the optical measurement, okay, by our naked eye. So for that we need a stock solution of Benedict, sugar solution, reducing agent, and then sodium hydroxide, because we need to measure 0.5 ml of Benedict solution and then 4.5 ml of glucose, and then the sodium hydroxide volume varies. Okay, let's do the sample 1 first. Okay, so for that we need to use burette. Let's fill this burette. Okay, since we are going to take 0.5 ml, we're going to add it in this. Okay, sorry, we are going to use the standard flask, 0.5 ml. Then we need to add 4.5 ml of glucose. So sugar solution is here, so we can use the other burette to this sample 1 sugar solution, 4.5. Yeah, or instead of that we can make it up. That's perfect. So it should be the lower meniscus. You should do it a bit carefully when you are closing this, and then you can shake this first sample so that the solution is homogeneous. So likewise, we can make the sample 2, sample 3, sample 4, sample 5 by keeping the volume of a Benedict 0.5 and then volume of glucose 4.5 and then varying the sodium hydroxide. So we have prepared various concentration of sodium hydroxide. So take 45 ml of this and then make all the other 4 samples. Now we have the various concentration, that is sample 1, we have like 0.5 ml of Benedict solution, 4.5 ml of glucose, and then we have rest 45 ml water. And then going to the second sample, which contains 0.5 ml of Benedict, 4.5 ml of glucose, and then 45 ml of 0.0001 molar sodium hydroxide solution. Likewise, so both the glucose and the Benedict are in the same volumes, okay, 0.5 and then 4.5, and then we just vary the 45 ml of sodium hydroxide solution from 0.001, 0.01 and then 0.1. Okay, so now we have the 50 ml of that. Our next task is to transfer this solution into a tube. Okay, so we are going to use these labeled tubes. Transfer first solution, which is labeled 1, to this one carefully. Now students, please carefully observe the color of the sample. We can see so most of them are having the similar color. Now we are going to heat this sample in the tube and then in a water bath. So what we are going to do is like we are going to transfer the sample into the water bath, that is the 500 ml beaker containing water, and then we will heat it for 5 minutes. So now you can see that in 2 minutes there is a change in the color. After 4 minutes, let's wait for 1 more minute. Okay guys, after 5 minutes keeping in a water bath, you can see that the Benedict solution, which was originally bluish green in color, okay, for all of them you can see after heating it the color has changed. Okay, you can see from the lower concentration of sodium hydroxide from yellow to reddish in color. Okay, and then we can also say that the size also varies. Okay. Okay, now let's go to the second part of the experiment. Okay, fine. Okay, so now let's do the second part of the experiment. Okay, so that is we are going to make these suspended solution, that is copper oxide nanoparticle suspended solutions, and then we are going to measure the turbidity of that. That's why I'm going to show you soon the turbidometer, how we are going to use it. Okay, so for this we already have the Benedict solution ready, okay, a stock solution, and then a glucose solution ready, and then here we need only sodium hydroxide 0.01 molar solution. Okay, so likewise, as I showed before, okay, we have to make 4 different samples labeled as A, B, C, D. Okay, and then to the first tube add 0.5 ml of Benedict solution. To that add 4.5 ml of glucose, that is a reducing agent, and then add 45 ml to the first tube, and then keep it to the water bath in a boiling condition for 5 minutes. Okay, and then you can see from varying from A to D. Okay, what you can see is like the molar concentration ratio between the Benedict solution and the glucose solution remains same, and then we are going to vary the sodium hydroxide concentration. Okay. Okay, students, as per our discussion on table 2, where we are going to measure the turbidity of the copper oxide, we have prepared the solution A, B, C, and then D. Okay, let's transfer the solution A to the glass vials or glass tube, because this solution also need to be heated in a water bath. So in all of this sample we are using 0.01 molar solution of sodium hydroxide. Okay, students, this is the second part of the experiment. This is the color observation that you have. You can see it like they are all almost on the similar color. That's because we have used 0.01 concentration of sodium hydroxide. Now our next task is to measure the turbidity of this solution. So once we complete the second part of the experiment, we have seen the reddish color of the copper oxide nanoparticles. Our next task is to measure the turbidity of this sample, and you know that this is the turbidity instrument, and then basic principle involved in the turbidity is like the turbidity will be related to the size of the particle, and also it will also determines the concentration. Higher the concentration of the suspension that is present, okay, and the turbidity will be very high, and then the larger the particle, the turbidity very high. So before start using this instrument, we need to calibrate this instrument by using a standard turbidity solution, that is 40 NTU. So let's take this standard solution to calibrate. I will put it into the instrument, cap it, and then calibrate to somewhere in the 40. It's ready to go. So now the next task is to measure the turbidity of the sample A, B, C, and then D. We have to take the 10 ml of, so for that we need to measure ten ml of this solution and transfer it in a beaker, and then we need to add conditioning agent. So conditioning agent, the role of the conditioning agent is to keep the particles, nanoparticles, to suspend, not to settle it, okay, which is the mixture of glycerol and then ethanol. So 10 ml of this. So this is the A solution 10 ml, and then 10 ml of the conditioning solution, conditioning agent, and then transfer it to the tube. Then need to clean this tube because it should not contaminate the instrument. Then put it back, then cap it, and note down the values. Okay, so in this case 86 NTU is the value for the concentration A. Okay, likewise you can take 10 ml of B and then into the beaker, and then 10 ml of conditioning agent, and then transfer it into the tube, and then measure all the turbidity coming out of other solution B, C, and then D. Okay guys, once you measure the turbidity of all the samples A, B, C, and then D, okay, so you can note it down, you can put the values here. Once you have this value, go for the plotting the data, that is in this axis quantity of sodium hydroxide and then turbidity. Okay, and then you will expect the curve or the plot starting from the origin. Okay, and then to understand this pattern, you can see that in the sample A we have 45 ml of sodium hydroxide compared to D, which is higher in concentration. That will push the reaction faster. Okay, and then what will happen is that will eventually increase the size and then increase the turbidity. So you may expect that decrease in the turbidity. Okay, so and then you can also see that the concentrate quantity of the sodium hydroxide decreases. Based on that, even though copper is present here in constant, the size also decreases. Okay, and then you can plot it from here. If your unknown copper solution, unknown sample has been given to you, you can plot it and then you can extrapolate it, and then you can determine the quantity of sodium hydroxide that has been used, and then from there you can back calculate, somewhere here in between, back calculate the copper has been given to you. Thank you.